The forecasts are that the climate change by the end of the 21st century will likely exceed 1.5 degrees centigrade relative to 1850 and 1900. So the IPCC is using a different type of forcings than they had in the past. If you're used to the SRES forecast, they were based on scenarios of growth in population and economic activities. And these have been replaced by what's called representative concentration pathways. There's a close relationship between some of the RCPs and the past forecasts. But let me I'll leave it to say that these are ranges of time it takes for the CO2 to double over time. And also the global mean temperature will continue to rise. These two figures here, one looking at temperature, the bluish or purplish is looking at models that tend to have an increase in CO2 at a much slower rate than the red models, but both indicate increases in temperature over time. And then the global sea level rise by 2100 being as much as about 2.5 feet on average for some of the higher emission scenarios. So, climate impacts. So we looked at real quickly at some of the data of what's happened in the past and what's being forecasted to happen. And these, of course, are all pictures of impacts of Sandy, not too far from us. So there's in the IPCC report, there's a list of identified climate impacts. And again, I'll try to go through these really quickly to get on with the other part of our talk. Terrestrial marine species having shifted their ranges, and these are identified impacts from the past. Terrestrial freshwater species face increased extinction, and many regions, precipitation and melting snow having been significantly altered relative to the hydrologic cycle. And then further future impacts, not ones we've seen, but sea level rise throughout the 21st century and beyond, and coastal systems becoming increasingly experiencing adverse impacts. And then finally, estimates by 2100, hundreds of millions of people being impacted. I just pulled this out. This is not from the IPCC report, but I just wanted to illustrate the kinds of impacts that we're talking about. This, of course, is New York. The blue was the current FEMA estimate of areas that would be impacted by a 100-year storm, a storm that would happen on average about 1 in 100 years. And what you see, of course, from figures like this, the yellow and the gold and the red, is that creeping into further inland. And what I would say about that is that even those widths are narrow, of course, there are billions of dollars of resources and millions of people on those areas. Okay, so I'm going to have 2 more slides and we'll move on to another topic. So in terms of, again, forecasts, the three of the more common forecasts suggest very large and irreversible regional scale changes in terrestrial freshwater ecosystems. And then the final bullet point here before I put heat stress and extreme precipitation and coastal flooding are going to impact urban areas. Okay, so let me proceed and say the following thing. When you see forecasts like that, you wonder, why don't people act? Why can't we take immediate action? And I was in a workshop yesterday, and Dr. Brown, Casey was in there with me, and someone asked me, how can you make decisions when there's so much uncertainty? And I can really relate to that. The answer I gave him yesterday was that, well, we have to deal with cascading uncertainties. We know that throughout our process, there's uncertainties associated with economic development. There's uncertainties associated with climate models. But even knowing that, I know that decision makers have a really large challenge. So, for instance, if someone asked you what would be the impact of climate change on Boston's water supply, what might they get? And in this case, what might they get from me if they ask that question? And hopefully, before I answer that question, I would ask them, what do you mean? What are the impacts of climate change? What do you care about? Do you care about the watershed from which the water is captured, or do you care about other things? And so if they were to answer to me what I care about is my ability to supply water reliably to the city of Boston, I might suggest that they go through a process, something like the following. After I've talked to them and done my best to understand their challenges, And that would be take the outputs from the IPCC as best we could that are at a very global scale, make mathematical attempts to downscale them, which is the second figure, into information that's appropriate for local decision making. For me, I would run them through a hydrology model to try to figure out what those climate changes, both in temperature and precipitation, might have in terms of runoff. I would have to figure out how their system is operated, which is the fourth figure. And then I'd try to give them a report back on what the impacts are. And either fortunately or unfortunately, I might give them something like this, and it would be really difficult in terms of maybe them interpreting it. So I might run a large number of climate models and extract from them the changes in temperature and precipitation. So this is 112 data points from 112 different runs, not all different models, but models with different assumptions about emission scenarios. So there's a crosshair there, and I want to make sure that we recognize that's not through 0, 0, that crosshair is for a different point. But I might give to that decision maker 112 different scenarios of what the future might hold. And some of those might make the decision maker nervous, and some they may not care. So across the bottom, I might say that the temperature changes might range from a half a degree all the way up to, say, 2.5 by 2030. And precipitation might range from a decrease in precipitation by about 5% all the way up to an increase of precipitation of 15%. That's really hard information to make a decision about. There's a wide range of that. And if I go forward in time and I say, well, what might happen in 2050? Oh, before I do that, there might be some really wide ranges. Like I said, some that are small in terms of temperature and low in precipitation, some that are high in both. Or as I go through time, I might say by 2050, that crosshair is moving towards even larger average changes in precipitation and larger changes in temperature. And finally, by 2070, even more. But one thing you notice as I flip through here, and I'll do it again, I'll do that again, is the variability and the range of forecasts are changing over time, getting more and less consistent, I think is a fair thing to say. So you know they're having a really difficult time with that. So hopefully I can translate that into something that they can find meaningful. And what I said, and again, this is another difficult graph, but what they might care about is the yield of the water supply, how much water supply that they can provide to the city over time. So these figures at the top, well, the columns are various years in the future, 2030, 2050, and 2070. And the top row is temperature change, and the bottom row is precipitation changes. So what you can gather from this, hopefully, through decision maker, is I don't exactly know what the temperature change might be, or exactly what the precipitation change might be, but I can see that as temperature increases, there's a very negative impact on my ability to supply water. And if precipitation increases, of course, I have the possibility of even having a larger yield. This can be done, of course, making a three-dimensional figure. I didn't do it for this talk, but basically you can look at the response to temperature and precipitation to the yield or state yield of that system. Still very challenging to deal with stakeholders. So what I would say is the following. Rather than trying to convince decision makers and stakeholders that we actually know the precise future, it's probably more effective to have them think about what the future might hold for them and how to adjust to that. So it really requires engaging stakeholders in a very meaningful way, not writing reports and handing them to people, but stepping back and understanding their perspectives. One of the things that I need to point out that uncertainties about sort of vulnerability, exposure, and responses to human and natural systems, they may be even larger than our inability to forecast climate in the future. And I think that example from the DC water supply system of where water demands have decreased dramatically over time is an example of where the social system actually dominates the climate system. So, let me just check the time here. Good. Approaches to decision making. When I'm going to talk about a couple of different approaches real quickly, and what I want to say is that when I sort of began my work back in the 70s, decision theory was a very popular way to approach this. And what I mean by decision theory is basically developing decision trees in which alternatives are put forward as probabilities and outcomes as economic perhaps impacts. And what you try to do is find the path through that network of decisions that might maximize, that might have the best expected value. What I would say to that is that people tend not to operate on expected value. And so over time, a lot of different approaches have come in to help people think about these complex problems and how to solve them. And so things that you see out now, things like threshold approach, many of you may have read books on catastrophe theory, where people talk about how to approach these problems from the worst thing that can occur. Scenario planning, which we've sort of mentioned, developing plausible stories to help people understand what might happen. And then one that I'm not very familiar with, that I sort of came across in getting ready for this talk, resiliency thinking, basically bringing experts together to find various ways you can deal with a problem, but from multiple perspectives. All of these sort of fall into what I would call structured decision making, which is an attempt to really reach decisions that are all based on achieving an objective. One thing that I'd say, I mentioned Casey Brown here, he's been very effective in promoting an idea that he's called decision scaling. I sort of am embarrassed to try to define it with him in the room, but I'll say that basically it's the use of an analytic method and basically trying to focus on the type of information that's needed for a particular problem that's at hand. And so his focus is on trying to understand the system first and maybe climate impacts later as they're appropriate to making decisions. And Tim mentioned this idea of shared vision planning. I'll say a few words about that. I'll just say something like the origin of shared vision planning. It really sounds like a nice 60s hippie kind of phrase, shared vision planning. I got it from Boeing Aerospace Company. Those folks would bring you bombers and stealth people. We were working with Boeing, and I discovered that they had developed this phrase, shared vision planning, for their engineers. They were very concerned about making sure that designs are good at the start and you don't have to redesign. So that was getting a good starting point for design was of great interest to them. I sort of rephrased it for our work in water resources, and basically I viewed it as something that combined a number of things, what I would call structured public participation, getting the public engaged in problem solving, collaborative modeling, and so in my career, the work that I did on Potomac that I mentioned earlier on, that was done on a mainframe that was in Minneapolis, St. Paul, which I interacted through a telephone by means of punch cards. The common way students interact with computers today. And so over my career, the change that's occurred has been dramatic, and our ability to build models collaboratively with people is really tremendous. And also part of shared vision planning is what I would call very traditional and disciplined planning approaches. One of the things that I would say that Dr. Brown's technique of decision scaling and what I've done with shared vision really share is this idea of co-generation information, the ability to work with stakeholders, to understand their problems to the point that you can really ask the right questions and formulate a solution that's appropriate for them. So that didn't, that's okay, I can't do okay. We just had 2 papers published late last year on this, well, that's really hard to read. One is on collaborative planning, the other is straight ahead on